A pharmaceutical company makes tranquilizers. It is assumed that the distribution for the length of time they last is approximately normal. Researchers in a hospital used the drug on a random sample of 9 patients. The effective period of the tranquilizer for each patient, in hours, was as follows. Number 1. X equals what? So the random variable that we're talking about, that we have data for, is the effective period of a tranquilizer. So the effective period for a tranquilizer. And it's variable because we have data that say it is. Excuse me. In hours. X bar. The average effective period. So as soon as we have the bar, that means we have an average, but it's the same thing. It's the if we add the word average, the average effective period in a sample of 9 doses of a tranquilizer. So again, this is in hours. And number 3, find a 95% confidence interval for the population mean length of time. Okay, we're going to ask GeoGebra for that confidence interval, but GeoGebra is going to want to have 4 things. The confidence level, 95%, so we have confidence level, 95%, or 0.95. It's also going to want the point estimate, the sample mean, and the sample standard deviation, and the sample size, which is 9. However, the paragraph doesn't tell us the sample mean and sample standard deviation, so that means it's our job to go find them. And we'll do that. We input the information here, 2.7, 2.8, 3.0. So 2.7, 2.8, 3.0, 2.3, 2.3, 2.2. What happened? 2.3, 2.3, 2.2, 2.8, 2.1, 2.4. 2.8, 2.1, 2.4. Now, we get the mean and the sample standard deviation. And now we have the information we need, 2.51 and 0.32. Now that we have the information, we can ask GeoGebra by using the probability calculator and statistics, and we want a t estimate of a mean. Confidence level is 0.95. The mean, 2.51. Standard deviation, 0.32. And sample size, 9. And there it is. Our confidence interval is from 2.26 to 2.76. So the confidence interval is from 2.26 to 2.76, and that's in hours. Number 4, explain in a complete sentence what the confidence interval means. So, what this means is we have 95% confidence that the true mean lies in this interval. And we have that confidence because excuse me, 95% of confidence intervals constructed in this manner will contain the mean. So that's really what it means. What we're saying is that 95% of confidence intervals constructed this way will contain the true mean. So we can be 95% confident that our interval contains the mean. Contain the true mean mu.